All right, this is a quick update of the Meshtastic version of the FPV detection node. In order to get Meshtastic working, I simply added a logic level shifter or converter from 5 volts, which is Arduino, to 3.3 volts for this ESP32 based Heltac mesh node. My phone is connected to a mesh node up on the window there over Bluetooth. That node meshes with this node, and then serial UART to the Arduino. So it is currently, the Arduino is on, everything is being powered via USB. So this USB-C has better power delivery than the USB Mini-B connector on the Arduino. So the one disadvantage of using this USB is that you don't get the Arduino serial printer for rapid updates, but it does give more power, so I figured that'd be the better option, is to use the higher power USB-C port. Those are rated for higher typically, so either way, either USB port can be used for that. So starting the test, I'll go ahead and plug in. I have a transmitter here on the desk for FPV. So if I go ahead and plug that in, it takes about 5 seconds that I have set up in the settings to lock, but then new contact locked, frequency is 5945, timestamp is the time in milliseconds that the Arduino has been running, and it'll give periodic updates. I have that update interval set to 10 seconds, so every 10 seconds it should print out a message giving an RSSI update as well. So let's say I put my hand over the antenna over the next update. Yeah, there we go. We see a drop in RSSI. So you could probably use this to this RSSI value for estimated power of arrival into the node there. And if you had multiple nodes sending these messages, you could probably estimate approximate position. What I'll go ahead and do is depower the transmitter and show you that update. So the RSSI dropped right there down to 347, and we'll see what it sends once it loses the lock. So there we go. Lost contact locked. It gives you the frequency again that it lost the contact, and another time span. So you have a duration sort of timestamp, and then you have the runtime since boot timestamp. So another thing I can do, let's say I want to send a message to the Arduino instead of the Arduino sending messages to me. I'll type in mesh test and send it, and it'll let me know once it's acknowledged. And so what just happened there is, over Bluetooth, I sent a message to that over the entire mesh network of the channel. So on channel 0, any node connected to channel 0 would receive that message. And so over that node, this node heard it, and you can see here I got the message, mesh test, but then I set this one up in serial text message mode. So over serial, it sent a text message, mesh test, to the Arduino. In the Arduino code, I have it set up to echo back the message to this node so that it sends to this node. And then coming from this node here, so the Arduino added on the echo string, as well as, it didn't add on, but it picked up the 1F8C, that is this node's device address, and 0B98, as you can see right there. This is like the full address, but the last 4 of this node's address is what I'm actually talking to on the channel. So you can see 0B98 is the node that I'm sort of texting through to, that I'm receiving messages from. And that way you can tell if you have, like, let's say you have 3 of these. Let's say I had 3 of these on my desk. By this little contact info right here, I could tell which node I'm getting the message from, but then it could also tell me which node that this device heard. And so I'm getting sort of like a multiple functionality over that messaging. So that's a quick update, hopefully not too confusing there, but all in all, pretty simple to, if I added like 5 or 10 or 20 more of these, whichever node was in range of this transmitter would then start pushing updates on this channel, and then whatever node I have connected to Bluetooth would then start printing updates to my phone. So that'll do it for this update.